Hi, today we'd like to explain how SingleSpa works. SingleSpa is a framework for developing micro front-end applications. In a micro front-end architecture, the web application is made up of several modules that are developed and distributed independently, and they are then composed within the browser. We will see how SingleSpa works by creating a smaller version of SingleSpa, which I will call MicroSpa. So let's go to it. Here on the left, we're seeing the example application that we want to develop. As you can see, there is a main page that contains a navigation bar. And if we click on profile, a profile application is loaded. And if we click on recipes, we go to the recipes application. If we look at the inspector, when we load the home page, what we're doing is to load a main bundle, container.js, that is loaded from the same server as the application, and then another bundle, navbar, which is the one that corresponds to the navigation bar application, which is served from a different URL. And also, if we go to profile, there is no hard reload. We just load yet another bundle from another URL, in this case from port 8081, and we mount it to the DOM to show the profile application. And the same happens for the recipes application. In this case, we unmount the profile application and we mount the recipes application. And again, the recipes application is served from yet another web server. So we want to create something like this. Let's go to it. The first thing we need is a container. So here I would create a container folder. All right, I will go to the container folder. I initialize a package.json file. So for simplicity, I'll be using a PNPM workspaces for handling dependencies, and and inside the container I need to add a few dependencies. So I would need webpack dev server. I would need the webpack command line, and I would probably also need HTML webpack plugin. Okay, let's load this dependencies. Right, then I definitely need a start script to start the server. So let's serve webpack, and just not to collide with the port of this other application, let's use a port 9000. Okay, all right, so this should be enough. PNPM start. All right, okay, so Webpack complains because it doesn't have a source file, so let's create a source folder. We put a very simple index.js file with just console log hello from container, yeah, like it. All right, so we can restart. Okay, so it's complaining about the mode option. Just to make Webpack happy, let's create a Webpack config. We'll need it later anyway. Okay, we set the mode to development, right? We can start serving. Okay, no complaints. Let's open the application. We cannot see anything. And this is because we don't have any static content to serve here, so we don't have an index.html. Let's create the index.html file. By default, it's under public, and so we will create a very simple page. Okay, like it, and then right, I want a body, and okay, this looks good to me, and I can close the body, I can save it. All right, I reload and actually I can see this static content, and that's okay. I have a very simple static page served with Webpack. At the moment there is no dynamic content generated, and what I actually want to do is to generate dynamically the content of the page. So if I go to the index.html file, by the way, if we look at the console, we see that there is no console log, and this is because if we look at the page, this file is not injected in the page. So we need to inject this file, and we also need to generate content dynamically. So to inject the file, we just go to Webpack config. We need the HTML Webpack plugin. So let's first of all load it, const HTML Webpack plugin, yeah, nice. And then here we new HTML Webpack plugin, and we want to specify the template. Okay, I want to inject the script at the end of the body, just to be sure that all the other elements have been already loaded when it gets to the script. So I will do inject body. Yeah. All right. Whenever I change the Webpack configuration, I have to restart. So I restarted. If I reload the source, I can see that now there's a main.js generated. Okay, just because this is the container, let's specify that the file name should be container.js. Okay, and yeah, and after doing this, if I reload Webpack and I reload the source, now the file is called container.js, and if I go to the page, I can still see the static content of the page. And this is where I want to start generating the content dynamically. So instead of console log, by the way, now we can see hello from container here in the inspector. So instead of console log, I want to take to generate some element. So const element document dot create element. And we want to set the inner HTML to something, for example, hello from container, and we definitely need to insert it somehow in the page. And one idea is to have a div which is the root of the container, and we can take this div, so const root, okay, it's called root container, yeah, and what we do is we append this child to the root element. Okay, so now you can see that actually this content is injected inside the HTML via the script, and this is all nice, but what we really want in our application is that the container shows the content set up by another application. So we need another application, in this case the navbar. So let's create the navbar. I can create it very quickly just by duplicating what the container does. Navbar. Okay, I have now the navbar folder. I need to add the workspace, and I need to just change all instances of container with navbar. Okay. All right. Another thing, I need navbar to be served on another port. So let's say we serve it from port 9001, and then we will need to install the packages for navbar, and we should be good to go. So if I start the navbar server, then this server will be served on port 9001, and I open it, and voila, I have my navbar application that generates this content, hello from navbar. So I have the container application, I have the navbar application, but what I want to do is to mount the content of the navbar application inside the container. So if I go to the index.js of the container, I would like to have something like this. So I want to import something from navbar, and I want this something from navbar to actually mount the content of the navbar application on the root element of the container. So for doing this, I need to refactor a bit the code of the navbar. So this part of the code is the one that actually generates the content and mounts it on the root element. So I can move this inside a function that would take a parent element, would generate the new content, and would just append this content to the parent element. And so just to make sure that the navbar application continues working, I can use the mount function on the root element of the navbar application if defined. So if I do this, I can still see the navbar application. Here we are on port 9001, and if I export this function, this mount function, I should be able to import it here from container and use it on the root element of the container this time. Okay, I try to do this, and if I go to container, I can see that I have a problem, cannot resolve navbar. So Webpack doesn't know how to find navbar. It searches for navbar inside the node modules folder by default, and it doesn't find it. To be able to load a module dynamically inside the browser, we need to use ES modules. To use ES modules, we need to modify a little bit the Webpack configuration. In the case of the navbar, to serve it as an ES module, we need to add some field to the output of output field of the Webpack configuration. So I have it here as a reference. I never remember the name. In this case, it would be a library field that has an attribute type that should be set to module. For it to work, we also need to activate this experimental feature. Despite it being a standard from, I believe, 2015, in Webpack 5 is still an experimental feature. Output module to true, and in this case we'll be transpiling. You will be creating the bundle as an ES module, and if I go to the navbar and I try now, of course I have to restart the navbar Webpack server, and I try to load it. I don't see anything, and this is because if I look at the page source, the navbar.js is still loaded as if it was a body script, and instead we need to tell the Webpack plugin to load it as a module. So in this case, it would be script loading to set to module. So by doing this and by restarting the Webpack, all right, then we can see that now navbar is loaded as a module, and if I reload this, we'll be able to see the module loaded correctly. Now we need to repeat the same configuration inside the container. So let's take it, go to the container, and we can actually copy it. We need to change this to container, and I think the rest should be okay. And of course we need to restart also the Webpack configuration. And still we have some errors, because if we look inside the index.js, we still are trying to import navbar in this way. And again, Webpack, whenever we have this type of references, will search for navbar inside the node modules folder. If we want to use to load dynamically the navbar application from another server, we will need to specify the URL, the full URL of the navbar bundle. So in this case, it will be HTTP localhost. It's not 88, it's 9001 navbar.js. So I save this, and as a matter of fact, now the compilation is green. And if I go to the container, I should be seeing the content mounted by navbar, but I don't see it. And actually I have an error here. We can see that the loading from 9001, trying to load the bundle in 9001 from 9000, from port 9000 is not allowed because of course policy. So we need to change the course configuration of the navbar server to allow to tell it that to send the course header. So in this case it will be dev server, and the configuration is headers. All right, and yeah, this is exactly the header that we want to add. GitHub Copilot is very useful in this case. We of course need to restart the Webpack server here, and we try to load it, and voila, we are now seeing the content mounted by the navbar application. And notice that we are here in server 9000, which is the container application. So we are inside the container as reflected by the title here, and we are mounting the content that is generated by the navbar application. So so far so good. There are a few things we don't like here. The first one is that in order for this to work, we had to set the full URL of the navbar bundle inside the code, hard-coded inside the code. And this means that if we ever change this URL, we'll have to change it in all the files that are referencing this bundle. Instead, we would like to be able to do something like, okay, load from navbar, and the Webpack would know where to take it from. To do this, there is a couple of things that we need to change. First of all, we need to tell Webpack that it doesn't have to search for it in the node module. So we have to tell Webpack that this is an external. And we do this by setting navbar as an external here in the configuration. And then we and this means that whenever Webpack transpiles bundles the code, it will leave the import that we see here untouched, because it knows that navbar is an external. This means that this input will get directly to the browser, and the browser will try to load the navbar module, but it will fail to resolve this module because it doesn't know where to take it from. And this is where import maps come into play. Import maps are becoming a standard in JavaScript. They have been implemented already in the main browsers around, and they are nothing but mapping between okay, so imports, they are mapping between identifiers, like in this case navbar, and the corresponding URL where the corresponding bundle can be found. So in this case, through this import map, we are saying to the browser, whenever you see an import from navbar, take it from HTTP localhost 9001 navbar.js. So we save this and okay, and yeah, so this is not script, it's script. Okay, and okay, this is invalid JSON. We have an additional closing folder. All right, yeah, and I have to change this. All right, so there's something wrong in here. Okay, yeah, this script. Right. All right, let's try and reload it. Okay, yeah, so after a bit of struggling with JSON, also I don't like very much this indentation. Okay, now it looks much better. Now the browser knows where to take the module navbar. And it's able to load the module navbar, take the mount function, and use the mount function on the root. So to summarize, until now we have created a container that inside the browser loads directly a module from served by another server, and it loads this module, it extracts the mount function exported by that module and calls this mount function on the root element of the container index.html file, or on the root element of the containers DOM hierarchy in the browser's page. Good. Now, if we look at the example application, what we had here is the possibility of browsing to different paths. And based on the path that we are browsing, the application would load and mount the corresponding application from a certain taken from a certain remote server. So we want to get there. So the first thing we want to have is different applications. So we need at least the profile application and the recipes application. We can do that simply by copying, just like we did for the container. We will copy the navbar into a profile folder and also a recipes folder. All right, and then we will just in profile we will change all occurrences of navbar to profile. Okay, and inside recipes all occurrences of navbar to recipes. Love it. Then we go to the PNPM workspace. We have another couple of packages here, profile and recipes. We need to PNPM install them. We need to serve them from separate ports. So we will serve profile from 9002 and recipes we can serve it from 9003. So let's go to the profile app and we PNPM start it. All right, let's see if it works. Lovely, the profile application works. And if we open another terminal and we go to recipes and we start that, we have the also the recipes application. They're all served from different ports, 9001, 9002, 9003, and then we have the container on 9000. Okay, now that we have that, we need in the container a few, in the navbar, we need a few links. And I've prepared some code to be copied okay, don't be too picky on it. It's just to create a few links, and yeah, you can see that here to allow to browse to different paths. So if I click on profile, I go to /profile, recipes, and home, I get to slash. And the way we do it is by setting the on-click method of this links to a function that changes the window history push state. This is because we don't want to reload the application, we want to navigate programmatically there. And as you can see, at the moment, they don't do much. They just call window history push state, which modifies the URL inside the browser, but this doesn't produce any result. What we want to do is that whenever we go to a certain path, the corresponding application is loaded. To do that, we definitely need to override the window history push state function. So we will inside here we are inside the navbar. In reality, we want to do it inside the container. Inside the container, we first take a reference to the original push state, and then we override the push state with a function that the first thing that it does is to call the original push state with the corresponding arguments, and then this is not a good suggestion by GitHub Copilot, and then it does something else, and this something else that we want to do is to mount the different applications, recipes or profiles, depending on the path. So we want to have something like if location.pathname equals /profile, then we want to call the mount function for profile. So let's import mount as mount profile from profile, and so we can mount profile to the root. If instead the window location path name is recipes, then we want to call the mount function for recipes. And for that we need to first import the mount function for recipes here. And okay, so this is okay, but we still the browser still doesn't know how to Webpack, and the browser still doesn't know how to resolve profile. So in Webpack we need to tell Webpack that profile and recipes are all external, so they shouldn't touch those imports, and we also need to tell the browser where to find them. So in this case, the profile can be found on port 9002, profile, and recipes can be found on port 9003 recipes. All right, okay, so all right, so we can go here. Of course, as usual, when we change the Webpack configuration, we should restart the Webpack server. We can go here, and I believe I've made some error. It always adds an extra comma at the end, and now we are able again to see the navbar, and if we click on profile, we should see the profile application being loaded, and indeed if we click on profile we can see profile. If we click on recipes, the recipes application will be mounted to the DOM. The only problem here is that if we click again on profile, again the profile application will be mounted and the recipes will stay there, and we can just mount as many copies as we want, which is not the type of behavior that we want. We want the navbar to be always there, but we want profiles and recipes to be mounted, unmounted, depending on the path that we're visiting. And this code is all hard-coded. We want to get something a bit more flexible, and this is where we start creating the MicroSpa library. So let me comment out this code. What the type of thing that we want is to, well, first of all, let's create a new file, MicroSpa, MicroSpa, which will contain whatever function the MicroSpa application library is providing. And here we will like, first of all, some code to register new applications. So we can call this function, say, register application from MicroSpa, okay, and we want to use it like this. So we want to be able to register all the application in a declarative way, and using, for example, an object that declares the several attributes that are typical of that application. So for example, for the navbar we have the name navbar. We need a way to construct an object that contains the lifecycle methods for that application. The mount method is one of the lifecycle methods that allow to orchestrate the mounting and unmounting of the application. So let's call this, I would call it load. This load method should be an asynchronous method that provides an object that contains the lifecycle methods for the application. So in this case, it would simply be loading the corresponding module. So in this case, we will have a function that loads input, that loads dynamically navbar. And then we want to have a function that tells us when the application is active. And in this case, we can call it active when, and it should be a method that returns true or false depending on several conditions. And whenever it's true, this means that the application should be active. So we know that the navbar should always be active, but whenever we declare, we register the profile application, then we can have an active that correspond to the condition path name is profile. Yeah. And similarly, we can register the recipes application, and this recipes application should be active whenever the path name is recipes. Okay, so let's implement this register application function. So this register application function just registers the application, and we can, inside MicroSpa, we can keep the list of applications that we are registering inside, for example, a global or a module-scoped array. So we export the function register MicroSpa, register app, which takes an app descriptor, and what it does is simply to push the app descriptor to the array. So it's called register application and register app. So let's call it register application. We save this and we reload this, and of course we need to go to root, and yeah, good. We are now registering the application, but we are not doing anything else from that. We also need to do something to mount those applications, and this is where we need a function that initializes the application by mounting the applications that need to be mounted. So inside MicroSpa we can export a start function that what it does, it basically does what the container was doing before. So it would take the root element, and then it would go through the apps that we have registered. Yeah, and it would check if the application is active. Then please load the application, and with the module that is returned by the load function, apply the mount function on the root element. All right. So this is good. We close this and we should be okay. Start is not defined. Yeah, we are calling start here, but we are not importing start from MicroSpa, so let's import it. Right. Okay, and then we have imported it, and now we can see again the navbar, because in MicroSpa the start function has gone through the applications. It has applied the active when, only active when, the active when of navbar returned true, because the other conditions are false, and then it mounted the navbar application. And if we go to profile, nothing happens again. Nothing happens again because we also removed the override that we did on the window history push state. So let's re-establish it. Okay, what do we need to do on each push state? On each push state, we need again to check what are the applications that need to be active and mount them. So in a sense, we will need to do exactly the same code that we have here in start. So let's refactor this code into a function that we can call reroute. Okay, so we have a reroute function that does all the job of checking if an app is active, loading it, and mounting it. And we can call this reroute when we start the application at the beginning, and also whenever we change the path with window history push state. So here we will call reroute. So let's go how this goes. Let's see how this goes. We need to be here to call the application. We go to profile, and as you can see under profile we have loaded both the navbar, which is always active, and the profile application. If we go to recipes, then we load the navbar and the recipe application. We can see that this is not exactly what we wanted, so the navbar is continuously reloaded. With the other applications that have active when return true based on the path where we are. If we want to avoid that, we need to keep track of which applications are already mounted. And if an application is already mounted, we should not remount it again. At the same time, if an application was mounted and it's not active anymore, then we need to unmount it. Okay, so we need to make our reroute function a bit more complex than that. So here, for example, we need to load and mount the application only if the application was not mounted already. To keep track of the fact that an application is mounted or not, we can modify the descriptor of the application and add an attribute that we call is mounted, isMounted is initialized as false, and whenever we mount the application, we set this isMounted to true, and therefore in this if we can add the condition if not app is mounted. So in this case, if the app is active and was not already mounted, then please mount it. At the same time, as we said, if an application is not active and was mounted, then we need to unmount the application and we need to set isMounted to false. Now, if you remember, we created a mounted function, but we didn't create an unmount function. In order to be able to do this, from each application, we need not only to export the mount function, but also the unmount function. So if I go to navbar, for example, I can export a function that's called unmount that takes a parent element. This function would remove child a certain child. And how do we find the child? So to be able to identify the child that we added, let's give this child an ID, a unique ID. In this case, it would be navbar. Let's call it navbar div. All right. So we here in unmount we do search for the navbar div, and then we parent remove child L. And this should be able to unmount the function. And we can do the same for the other applications. For the profile application, we can export an unmount function that takes the main element for that application. Of course, we need to set the ID to be able to find it later, and then we find it and we remove it. And the same we do for the recipes application. So we need again to set the ID to recipes and remove it here. Okay, so let's check the code. Okay, looks good. So we are exporting now from the module the mount and unmount function. And if we look at the code, we can notice that the code in the container in MicroSpa, in the reroute function, we can see that whenever we want to mount the function, we first load the module and then we call the mount function from the module. But when we need to unmount it, then we don't have the module itself. We can of course call app.load again. Since the application was already loaded, by calling load it should return the same instance of the module that was loaded before. But just for simplicity, one thing that we could do when we first mount the application is to save a copy of the module inside the app descriptor itself. So we will save a module in app module so that here during the unmounting we can just call unmount from the app module itself. Okay, so we save this. If we go to profile, we are loading the profile. If we go to recipes, okay, we have a problem here. Oh yeah, I didn't save the profile. Okay. All right. So, and yeah, if I go back to the application now, if I click on profile, I go to the profile and the profile application is mounted. And then if I click on recipes, then as you can see, the recipes application is mounted and the profile application is unmounted. All right. Now, one of the problems that we have here is that if I reload the page here at recipes, then I cannot get /recipes, and this is because Webpack is trying to search for this path and it doesn't find it. This is a single page application, and we need to tell Webpack that each path should be mapped back to the root. This is done by setting inside the container in the Webpack configuration by setting an option of the dev server, which is history API fallback to true. We will need to restart the container, and by doing this, any path is mapped back to the root. So if I reload this on recipes, then we can see that it immediately loads recipes, and if I go to profile, it still works. If I go to home, I just see the navbar. Fantastic. There's still one thing that won't work here. So I go to profile, then I go to recipes, and then I try to go back. And as we can see, even if I'm now at the profile path, the profile application is not loaded. So how do we solve that? Whenever we click on the back on the forward button, an event is generated which is called pop state, and in order to be able to do something when we click those, we need to add a listener for that event, and in this case it would be as simple as adding a listener for the pop state that will call again the reroute function. So if I save this and then I reload, then I'm under profile, I can see the profile application. I go to recipes, it loads the recipes application, it mounts the recipes application. I go to home, and then if I go back, I now can see correctly the recipes application, the profile, the home. I can go forward, I can go back, and it all works. And this completes the coding session and the explanation about the MicroSpa application. Library. So to summarize, what we did today was to generate a small sample micro frontends application that has a container that is capable of loading, mounting, and unmounting different micro frontend applications depending on the path that we are browsing. And we did this by using ES modules and import maps for convenience, and by having each micro frontend application export a couple of methods, mount and unmount, that allow that application to be mounted and unmounted on a root element inside the container, and by also creating a register application function that allows us to register application and specify for them a way to load them. In this case, we are loading them dynamically. But what is important here is that we have a function that returns an object that contains those lifecycle methods, mount and unmount. And the register application also provides a function that tells our MicroSpa library when when a micro frontend application should be active or not. In this case, we did it based on the path that we are browsing. We inside MicroSpa we have overridden the push state, and the push state function of the history API, of the Windows.history API object API, and we also added a listener for the pop state. This means that the events that evaluate the active when function, so that decide when an application should be active and therefore mounted or not, those events happen when navigation happens. And this is why the active when function should be something that depends, or better said, is something that is best implemented as something that depends on the navigation, on the path where we are, or on, in general, navigation events inside our application. I hope this gives you a better understanding of how SingleSpa works. Of course, SingleSpa is much more complicated than that. It has to handle edge cases. It has to work with all main frameworks, Angular, Vue, React, and therefore it has adapters that provide these lifecycle methods for all those for applications written in all those frameworks. But still, in its very core, these are the concepts that will allow you to understand how the library works.